In example 5, I'd like you to determine the area under the normal curve between each of the pairs of z values. So we've got 4 different pairs. Again, it's really important. I can't emphasize enough that you need to be able to draw a picture of each of these or sketch a picture of a normal curve. And I've got the curve here for you. So in each case, we'll sketch a picture, locate the z values, find the area under the tables, and then make our conclusions. So in the first case, we're asked to determine the area between z is equal to 1.2 and z is equal to negative 1.2. So with a standard normal curve, we have the middle at 0 and 1, 2, 3 standard deviations, and minus 1, minus 2, and minus 3 standard deviations to the left. Z is equal to 1.2 is on the positive side of the mean, so we've got 1.2 here, and there's our middle, and we want to go from z is equal to 1.2 to z is equal to negative 1.2. That would be to the left of the mean, so negative 1.2 would be over here. So we want the total area between the two z values. So now let's go to our z tables or our normal tables and say for a z value equal to positive 1.2, and remember that it's the same on either side, positive 1.2 and negative 1.2, it's still the same distance from the mean. What is the area that corresponds to that? So look that up in your tables. And so here's our normal tables, and we're going to find the z value of 1.2. So we're going to scroll down this list to get to 1.2, and it's really just 1.2. So there it is. I'm going to stop right there and go right over to 1.20. And that gives me an area of 38.49%. So I'm going to record that. So we have an area for a z value of 1.2 of 38.49%. So what does that mean? That means that the area between the middle and the 1.2 value is 38.49%. Now we also have a z value that is negative 1.2. So that would be the same area on the other side. So that would be 38.49% because it's the same distance on the other side. So what's the area between negative 1.2 and positive 1.2 in our z or in our normal distribution? Well, that area would be twice 38.49%, and when I double that area, I'll end up with a total of 76.98%. So there's 76.98% of the total area under the curve is going to be between plus and minus 1.2 standard deviations of the mean. Now let's take a look at part B, where we're asked to find the area between z is equal to 1.5 and z is equal to 2.8. So there's two different z values. Well, where is z is equal to 1.5? Well, 1.5 is halfway between 1 and 2. So z is equal to 1.5 is here, and z is equal to 2.8 is somewhere out here, 2.8. That's between 2 and 3. So we want the total area between those two z values. What that means is that we're going to have to calculate two different areas from our normal tables. We need to calculate an area for z is equal to 1.5, get the area for that, and we also need to take the z value of 2.8 and calculate the area for that z value, whatever that is, and we'll do something with those two areas. So let's go to the tables now. So taking a close look at our normal distribution tables, or table A1, when I scroll down the list to a z value of 1.5, that corresponds to an area of 4332 or 43.32%. Now let's go down the list and find the area for a z value of 2.8. So I got to go all the way down to 2.8, and at 2.8 it corresponds to an area of 49.74. So let's record both of those and go back to our calculations. So with a z value of 1.5, we received an area of 43.32%. So what that means is that between z is equal to 0 and z is equal to 1.5, that accounts for 43.32% of the area under the curve between 0 and 1.5. And additionally, we also know that at z is equal to 2.8, the total area from 0 to 2.8 amounted to a total of 49.74%. So how are we going to calculate the area that's between the two? Well, I'm going to take the total area of 49.74% from 0 to 2.8 and subtract the area between 0 and 1.5. So the area between Z is equal to 1.5 and 2.8 is going to be calculated as 49.74 subtract 43.32%. And that area works out to be 6.42%. So there's only 6.42% of the area between those two given Z values. Now in part C, we're asked to determine the area between Z is equal to negative 2.75 and Z is equal to 2.0. So let's locate those two Z values on our normal curve. Minus 2.75 is to the left of the mean. So minus 2.75 is going to be approximately here. So minus 2.75 will be to the left of the mean, and positive 2.0 Z value will be to the right of the mean. So 2.0 will be to the right of the mean. So we want the area that's between those two Z values. So again, we're going to have to go to our normal distribution and get the area for a Z value of negative 2.75, and we'll also need to get the area for a Z value of 2.0. So let's do that. Let's get both of those areas and then come back. For a Z value of negative 2.75, I'm going to go down the Z column to 2.7, and here we are right here, and I'm going to go across to 2.75, and that would correspond to this column right here, 49.7%. So we'll circle that, and then we'll move on to finding the area for a Z value of positive 2. So at positive 2, 2.0, that would be 4772. So that would be located right here. So 47.72%. So now I have the two areas. I'm going to make a note of them and solve the problem. And so the area corresponding to negative 2.75 was 49.7%. And the area corresponding to a Z value of 2.0 was 47.72%. And so what that means is that I can go back to my diagram now and indicate that the area between 0 and negative 2.75 is 49.7%, and that the area between positive 0 and positive 2 would be 47.72%. So how do I find the area between the two? Well, I'm going to simply add them. So in other words, the total area is going to be, since they are Z values that are on opposite sides of the mean, the total area will be 49.7% plus 47.72%. So that gives us a total area of 97.42% between the two. 42%. And of course that means that the rest of the area, which is approximately 2.6%, is going to be in the two tail areas there. So 97.42% is going to be between those two Z values. And the last part of this exercise is to determine the area under the normal curve between negative 1.95 Z value and a negative 1 value. And you'll notice that both of these Z values are on the same side of the mean. So in other words, they're both on the left of the mean because they're both negatives. So for a Z value of negative 1.95, well, that would be approximately here. So minus 1.95 is to the left of the mean. And a Z value of negative 1 is also to the left of the mean. So there's the Z value of negative 1. So again, we're going to have to go to our tables and determine the area that's for a Z value of negative 1.95, and also determine the area for the Z value of negative 1 and do something with those areas. So let's step aside now. Now for a Z value of negative 1.95, again, I think we've already calculated this one. It's going down to negative 1.9 and going across to 1.95, and that corresponds to 47.44. 47.44% of the area between 0 and minus 1.95. The area for a Z value of negative 1 corresponds to 34.13. So circle both of those and make a note of the percentage areas and go back to solving the problem. So what have you determined? That the area between 0 and negative 1.95, that area corresponds to 47.44%. So the area from here to here is 47.44%. The area between 0 and negative 1 corresponds to an area of 34.13. So this area between 0 and negative 1 is 34.13%. So when the area between the two z values are on the same side of the mean, what we're going to do in order to determine the area between the two z values, we really want this area between those two z values, what we're going to do is subtract the two. So the area between z is equal to -1 and minus 1.95 is going to be the difference between the two. So we're going to start off with the 47.44% area, and we're going to subtract from it the 34.14%. And so that area difference works out to be 13.31%. So you can see how critical it is to make a drawing or a sketch of the normal distribution when you're answering these questions. You need to know whether you're on the same side of the middle of the curve and whether you need to add or subtract the two areas that you get from your normal tables.